Hello everyone. We're going to look at our second lesson on differential equations today, and we're going to take a look at two AP questions. However, before we do them, I'd like to look at these two indefinite integrals that require U substitution. Take a minute and do them and see if you could find a shortcut. This will make our differential equations much easier. So pause the video and try these two problems. Okay, so in the first problem, we have a composition of sine and an angle. The innermost function is the angle, which is 5x plus 2. We start differentiating it. We cross multiply. And we always bring the coefficient on the du side so it matches the rest of the integrand. So we get 1/5 du for the dx and sine u, and the antiderivative of sine is negative cosine u, which I'll put down the 5x plus 2 back, and the 1/5 goes in the front, plus c. And this is our answer to the first problem. In the second problem, we have an exponential function, and the exponent is a function of x, so that is our u. And we differentiate that. Du dx is 3. Du equals 3 dx. Dx is 1/3 du. And when we substitute, we get e to the u times 1/3 du. And our answer is 1/3 e to the u, and we'll put back the 3x minus 4 plus c. So now I'd like to discuss a shortcut. Rather than going through all of that u substitution, how can we get the answer very quickly? Well, the idea is this. The coefficient is always the reciprocal of the coefficient of the x, but that's only if u is linear. So let's write that down. If u is in the form of ax plus b, the coefficient in the antiderivative answer is the reciprocal of a. Or just 1 over a. So if we want to integrate sine of 5x plus 2, we take the antiderivative of sine, which is negative cosine. We carry down the u and multiply it by 1/5. And the antiderivative of e to the 3x minus 4, well, e to the u, the antiderivative is itself, but we multiply it by 1/3. So keeping that in mind, I'd like you to do these two without u substitution. Okay, pause the video and try these yourself. All right, so let's look at number 3. So u in number 3 is 5 minus 7x, so that will appear in the answer for the antiderivative, and the coefficient is the reciprocal of negative 7. So we have negative 1/7. The antiderivative of secant squared u is tan u plus c. And there's our answer. In the next one, it's a little tricky. We see a function to a power. We'll probably use the power rule here. Notice that this is our u, and we could rewrite this as 3 minus 10x to the negative 5 dx. Remember, when there's a fraction and we have a binomial denominator, we could always make that denominator to a negative exponent. So our u here is 3 minus 10x. So the coefficient of our answer is the reciprocal of negative 10, which is negative 1/10. The antiderivative of u to the negative 5 is u to the negative 4 divided by negative 4 when we add 1 to the exponent, plus c. And that is our answer for the next problem. So remember, this could be done only when the inner function is linear. If the inner function is not linear, then we have to go back to our u substitution. This does not always work, but usually the inner function is linear. It seems to be very popular on the AP. Okay, let's take a look at this AP problem that was given in 2000. All right, they give us a differential equation, dy dx. Oops, just get my pencil out. Dy dx equals 3x squared over e to the 2y. And part A says solve it using the initial condition f of 0 is a half. So we cross multiply. And then the y is with the dy. The x's are with the dx. So they're separated. We integrate each side with respect to that variable. Remember, we always add the c on the x side. And the antiderivative of 3x squared is easy. That's just 3x cubed over 3. The antiderivative of e to the 2y dy, well, this requires u substitution, but u is linear. It's 2y. So the coefficient in the answer will be a half, which is the reciprocal of the 2. The integral of e to the u is itself. And that's it. We don't have to add the c because we already added the c on the right side. Okay, now as soon as we integrate, we substitute our initial condition. X is 0 and y is a half. And this is from this point that's given in function notation. So we carefully substitute 1/2 e to the 2 times a half equals 0 cubed plus c. So c is simply 1/2 e, which is a very strange constant, but that's the constant. So our function is 1/2 e to the 2y equals x cubed plus 1/2 e. But notice that they said to find y equals f of x. So in order to find y equals f of x, we have to isolate the y. The y is an exponent, and we've got a few barriers. It's multiplied by 2. The base is e, and we have a coefficient of a half. So we work from the outside in. First, we'll try to remove this half by multiplying everything by 2. So we get e to the 2y equals 2x cubed plus e. Now, to remove the e, well, what function can we use that will remove e? The natural log. When we compose the natural log function and e, they cancel. And because the natural log function is a one-to-one function, we can take the natural log on each side. Just like we take a common log on each side back in the 11th grade. But this has to be in parentheses on the right side because it's the natural log of the sum. Okay, so the ln and e cancel. We get 2y equals ln. And here we cannot expand this because it's the log of a sum. So we just leave it. We divide each side by 2. And the answer is 1/2 ln of 2x cubed plus e. And that is our function. Notice that the algebra did not yield to functions. We would get two possible functions if we had a y squared, but we don't, so this is the function. Now, part B says, find the domain and range of the function found in part A. Well, we have to realize that the domain of a log function, this piece, has to be greater than 0, and it can't equal 0. So we set 2x cubed plus e greater than 0, and we solve. So we subtract the e, we get negative e, we divide by 2, and then we take the cubed root on each side. And this is the domain. The range, well, the range of any natural log function is all of the real numbers. And that's the answer to that particular AP. All right, now this problem was given 2 years ago, 2018, and they gave us, and it's the 6th question, as you can see. They gave us this differential equation right here, but this time they asked us to draw a slope field. Well, to sketch the curve through these 2 points given its slope field. So with differential equations, I've seen questions where they ask us to make a slope field. I've seen questions where they give us the slope field and we have to identify the function of the differential equation. And there are other questions where they give us a slope field and we have to use the slope field to sketch the curve through the given points. And those are a little bit more challenging, I think. So let's I'm trying to erase this here, but it's not working. Okay, it's not working here for me. All right, so how do we do this? This was given on the AP, and they gave us these 2 points. So this is really a question for an artist, I would think, because I have trouble doing this myself. So what we do is we just follow the curves. Just follow the lines. And you see that here it seems to be bending up again, so we'll just connect it this way. Something like that. Now, through this point, though, notice that the lines are straight, horizontal. So I'll just follow those. And that would be my solution. Very strange, but that's the solution. And that problem, believe it or not, is worth 2 points. It was 1 point for this curve and 1 point for the horizontal curve. Now, what students tried to do was to try to connect the 2 given points. Don't do that. There are 2 different graphs through each point. Okay, so that's that question. All right, now part B says, let f of x be a particular solution to the given differential equation with the initial condition f of 1 equals 0. This is very similar to the one we did before. We have to solve for y, given this point, which again will be used to find the c. Write, and then they proceed and say, write an equation for the line tangent to the y equals f of x at x equals 1. Use your equation to approximate 0.7. Okay. Well, let's take this one at a time. All right, so part B says, well, actually, if I look at it carefully, they say that's the solution, but we really are going to find the solution in part C, because it says find the particular solution y equals f of x. Okay, but here they say that if there's a solution, we can write the equation of the tangent line using this differential equation at x equals 1. So what we'll do is, because we have the initial condition f of 1 equals 0, the point of tangency is 1, 0. To get the slope of the tangent line, we substitute into the differential equation. So we get 1/3 of 1 times 0 minus 2 squared. And when we work that out, the answer should be, I believe, 4/3. So the equation of the tangent line in point slope form is y minus 0 equals 4/3 times x minus 1, or simply y equals 4/3 times x minus 1. And this can approximate the curve for all points near 1. So our approximation at point 7 would be 4/3 times 0.7 minus 1. That's 4/3 times negative 0.3. So that's 4/3 times negative 3/10. These divide through, and the answer would be negative 4/10, or negative 0.4. And it's not incorrect to say it's equal to negative 0.4. That is our answer. This is the tangent line approximation. Okay, now part C says, solve the differential equation with the initial condition. Notice it says, find the particular solution y equals f of x. Okay, so we'll do that on the next page. All right, now this differential equation is a little trickier, but we can handle it. So let's proceed. I'm going to put this, well, I will rewrite it as follows. I'm going to put it over 1, and we're going to cross multiply. So we get dy equals 1/3 x times y minus 2 squared dx. Okay. Now, did everyone follow this? We multiplied the dy by the 1 and the dx by this whole thing. This whole thing. All right. Now, here we have to separate the variables because notice that this expression is on the dx side. So what we'll do is we're going to divide each side. We're going to divide each side by y minus 2 squared. We never divide by dy and we never divide by the dx. Only the expressions with x and y's by themselves. So I'm going to divide this by y minus 2 squared. And the reason why I did this is because these now divide through, and I've separated the variables. I have dy over y minus 2 squared is equal to 1/3 x dx. All right, so now my y's are on the dy side. Even if I'm dividing with an expression by y, it's okay. And the x's are with the dx side. And this is fine because when we divide with an expression with y or x, we could rewrite this using a negative exponent. Remember, the power rule. We're going to use that. Okay, notice I didn't bring the 1/3. I let the 1/3 stay where it fell. Now we're going to integrate each side. And notice that on the left side, we need u substitution, but we're going to use our shortcut. On the right side, we don't need u substitution. So the integral of 1/3 x with respect to x is 1/3 times x squared divided by 2, and we agreed that the plus c goes on the x side. In this one, we know that our u is y minus 2. So this is u to the negative 2 with respect to u. And notice that the coefficient of the linear term is 1. So the answer in the antiderivative will be the reciprocal of 1, which is 1. So we could proceed by saying that the answer will be 1 times, and the antiderivative of u to the negative 2 is u to the negative 1 divided by negative 1. So here we would have y minus 2 to the negative 1 divided by negative 1. And that's it. We're done. And we don't have to put a plus c here because we agreed that the c will be on the side. So let's go over the shortcut again. So we know the u's linear. So the coefficient in the answer will be the reciprocal of the coefficient of the y, which is 1. We integrate u to the negative 2, which is u to the negative 1 over negative 1, and we substitute the u back. All right, now we have to solve for the y. Oh, before we solve for the y, we have to find our c. This is important. Immediately, let's find c. So I could rewrite this as negative 1 times y minus 2 to the negative 1 equals 1/6 x squared plus c. I could even write it as negative 1 over y minus 2 to the first equals 1/6 x squared plus c. Now let's substitute. X equals 1, y is 0. So we have negative 1 over 0 minus 2 equals 1/6 1 squared plus c. So we keep going. We get 1/2 equals 1/6 plus c. So c is equal to 1/2 minus 1/6. So when we rewrite this as 3 over 6 minus 1 over 6 equals c, c comes out to be 2 over 6, which is 1/3. So let's write our answer on the next page. Was to get the integral here. You know, separating the variables and getting the correct integral. But after that, it's substituting to find c and isolating y using algebra. A brief comment. And our answer is negative 1 over y minus 2 equals So we have negative 1 over y minus 2 equals 1/6 x squared plus 1/3, because that was our c. Now, the rest is algebra. From here, it's all algebra. And now we have to solve for y. So let's think about the best way to solve for y. Well, I think because we have so many fractions here, let's get the fractions here with a common denominator of 6. So we'll get negative 1 over y minus 2 equals, the common denominator is 6. So 1/6 x squared is x squared over 6. And then I have to multiply the 1/3 by 2 over 2. So I get this. X squared plus 2 over 6. Now, there are shortcuts with proportion. We could cross multiply and divide, etc., etc. But there's a property that says that if A over B equals C over D, then the reciprocals are the same. B over A equals D over C. So because I want to isolate the y minus 2, I'm going to rewrite this as y minus 2 over negative 1 equals 6 over x squared plus 2. And then what we could do is, because we want to isolate the y, right, we're going to multiply each side by negative 1. So we get we get y minus 2, and I'll bring the negative 6 up here. And then we'll add 2. So our answer is y equals negative 6 over x squared plus 2 plus 2. Or on the AP answer key, they have it this way. Either one is fine. And we didn't have two solutions. And this is true for all x. X could be any element in the set of real numbers. Okay. All right, so that takes care of that AP question. And notice that there is more algebra in these problems than there is integration. The hard part on how to solve this equation here, we could have also cross-multiplied. There's nothing wrong with that. But this we would have to put in parentheses. Divide each side by x squared plus 2. And then added the 2. There's so many ways of solving it. But either way, it is correct. I mean, whatever you feel more comfortable with. Okay, so that takes care of our AP questions, and tomorrow we'll take a look at a few more. Have a great day and stay well.